Good morning, Dallas. Good morning, US, and good evening, India, and good evening, Bangalore, that is in Karnataka state of India. So, why we are saying Bangalore is obviously you will know in a short period of time, but before that, today's interesting topic that we all should be aware of, and you are aware of because we do advertise that on the poster as well as on the YouTube link. And it is a very, very, very important topic because without taking care of that, electronics manufacturing becomes a big challenging work. And as it says, electrostatic discharge, right? But to talk about ESD or to talk about electrostatic discharge, we have a special guest today. And just to give a brief introduction about the guest, he is highly educated and highly learned individual in the engineering field, and that too in the electronics field, I would say. And he is IPC trainer, and also he holds an IPC trainer certificate, or I would say some kind of a value which is called a CID, and he trains people on various field. But of course, he will correct me if I've been a little bit here and there. But ladies and gentlemen, he is an experienced individual and a technical advisor in the electronics manufacturing field. Let's welcome him. His name is Mr Ankan Mitra, and he lives in Namma Bengaluru, that is in Bangalore, in Karnataka. Welcome to Electronics, Global Electronics Show, Ankan. Good evening. How are you this evening?
Good evening, Rajiv. Thank you for the introduction and the kind words. And I'm doing fantastic and really looking to interact with you. Thank you.
Absolutely. Thank you very much. I know how busy you are, and you're also today you're taken this call from your car. That shows that you know in Bangalore it's very difficult to reach from one point to another point, and under the commitment that you give, to people, because you never know when the traffic can definitely make you more challenging, to reach those places. But thank you very much for allowing your time to devote with the global electronics and to talk about the challenges that we face in the electronics manufacturing. And today's we have, the topic we have chosen is ESD, that is electrostatic discharge. And for the people, of course, in the electronics field, everybody knows what is electrostatic discharge, but it's a sudden release of static electricity that can occur when two objects with different electrical properties, come into contact, and that will definitely potentially harm the components which are used on the electronics manufacturing side. So Ankan, let's begin. I know that you manage a company which is engaged in heavily into the ESD auditing, ESD training, ESD material, and so on and so forth. So can you give us some introduction about you and your company?
Thank you. So maybe I can, if possible, maybe quickly try to share my screen and and try to introduce ESD India. So just want to confirm that you're able to see my screen.
Yes, we can. Absolutely.
Okay, great. So, ESD India is basically the focus is excellence in ESD engineering. Yeah. And the team had been the first certified team in India in the domain of ESD. And, over a period of time, we have made a core set of team members from IITs, from Indian Science, who are working in this particular domain, who are part of our team. And we are also pan India located, in of course in Bangalore, but also in Visakhapatnam, Pune, Noida, and in recently in Ahmedabad, considering the growing semiconductor scenario. And as you can see, we have been supporting customers since 2009. Many customers across leading brands we are engaged with. Yeah. And another thing is we are speaking in all different languages, because I mean, somewhere we have to speak in Gujarati, somewhere in Tamil, somewhere in Kannada, in Telugu, of course in Hindi. So, we are speaking the language so that, the intention is given. Yeah. And this is basically ESD India is part of overall group, which is WMG Electronic Solutions. And there is another team under WMG called Spark, who is specifically into test and measurement equipment, basically who is ensuring the future of ESD measurement is done one by this particular team actually. Yeah. So I'll stop and back to you. Try to answer questions.
Absolutely, absolutely. I mean, it's very good to know, that you are expanding within India, and as you rightly said, ESD is definitely a huge and a greater and an integral part of electronics manufacturing. And normally, like how the ESD happens.
So, I mean, as you mentioned, Rajiv, that ESD is because of friction between two surfaces, yeah, and it can be any surface. I mean, when we are talking about surfaces, it's not only the from what materials comes into what we see physically, but even liquids, the air that comes into picture, because when we do hot air gun rework, etc. So it comes everywhere actually, yeah. So I mean, one of the key things I'll take a step back, try to answer your questions. But one of the things that we do is failure analysis. So this is basically the summary of failure analysis that we did in 2013, and we continue to see that 20% of the failure that's happening in the electronics industry is because of ESD, even though it has the protection mechanisms have matured so fast. Yeah. So so much. Even then, 20% of it is because of ESD, and one of them happens still because of human body. I mean, this is a popular TV actor, yeah, but it is not only between the actors and actresses, but still human body continues to be one of the major sources of ESD. And I'll talk a bit about it in a moment. The other thing is powered up tools that we use. It can be anything from your soldering station, torque screwdriver, your oscilloscopes, your multimeter. So anything like that which requires power can be another source of ESD. Other thing is the materials which comes in contact with the components, like your packing materials, the tubes, the trays, all of that. So that is another key source. And then the other aspect is the non-power tools. So basically anything like tweezers, cutters, pliers, everything comes into picture. Yeah. Now, if I take a step back and talk about human being, now we only had been looking at the resistance, net resistance of the human being who's working in the shop floor. Yeah. But that is not enough, actually. We also need to look at how much charge generation is happening. Yeah. And so what I've done is, I've kept the standards also, the relevant standards that are applicable for these limits. So these are the limits. And in many, many factories, we have seen that even though the resistance parameter is meeting, for the human body or the person or the staff who is performing the activities inside the shop floor, their charge generation is way out of the acceptable spectrum, actually. Yeah. So that is one of them. Yeah. Now, the other thing is when we talk about the tools, you know, we see still look at the the resistance of the tool, but what happens is these tools which are powered up like soldering iron, it directly touches the pins or the terminations of the components. And if you have a tool or an equipment which gives leakage voltage, then that directly injects leakage voltage onto the component. Yeah. So basically ensuring the right grounding, ensuring the leakage voltages are within the limits for the tools is another, key prevention mechanism. The third part is about the packing materials. Yeah. So, I mean, any packing material that comes into picture, whether it's bubble sheet or the silver color bags, which is basically the static shielding bag, or the trays or the tubes, this needs to have voltage level as low as possible when it is coming with that particular component which we are using for packing. Yeah. And the last one which I want to talk about is the tools which we use, even for example the tool which we use for removing the solder ball, which is just a metal pin, or the tweezer or the or the plier. All of this comes under something called as isolated conductor, and the maximum allowed voltage on the tip of this tool is 35 volts. Yeah,
Wow.
and many places we have seen that the ESD event is happening from this tool, which is actually no one would suspect at all. Yeah, so these, I mean, broadly speaking, Rajiv, these are the four sources and the limits and the corresponding standards which we see, and which continue to be the source of ESD, and we need to work towards preventing that. Yeah.
Wow, excellent. I think it was fantastic and a brief but elaborative description about how ESD does happen and what are the actual, the key factors are engaged in forming the ESD. Let's take a quick break here and we'll come back how we prevent this and further action. Small break, and we have today Mr Ankan Mitra from Bangalore, Karnataka, who is a technical advisor for the ESD India team in India, based out in Bangalore. And today we are talking about the electrostatic discharge in the electronics manufacturing. Yes, it's a very important factor and to be actually given a lot of importance because that can malfunction the components, that can malfunction the circuits, the design, and the whole works as far as electronics manufacturing is concerned. Welcome back, Ankan, after this small break. And so you mentioned about the factors engaged in forming a ESD. And now let's talk about how we can prevent ESD and how ESD in can help on this.
Right. Some of the conventional techniques continues to be. Thank you, Rajiv, for the break and the welcome back.
Sure.
And so so answering a question, um, uh, some of the conventional techniques that are like periodic measurement, etc., is continues to be very effective, in fact. Yeah, and we have seen that many places the control mechanisms, and also based on the CTQ areas within the production or in the lab, is that where they do more frequent measurements, basically, and then they try to understand that yes, whatever they're using out of the four parameters what I mentioned are within the limits, basically, or their tolerance may be internally defined, so those tolerances may be much more tighter than what is there in the standard. Yeah, now the world is moving towards a bit more advanced techniques, and what that technique is like ensuring automated measurement. Yeah, now what I mean by automated measurement is that we have um, different types of equipments under this brand called uh, Spark. Yeah.
Uh-huh.
So
Yeah.
what they do, what it does is, we can measure up to, for example, 6 workstations or 6 measurement points, ensure all the data that is there through Arduino and ESP moves into cloud, and then the data that is there in the cloud moves into a dashboard for the customer. Yeah. Now, what that means is that at any given point of time, the customer can have multiple equipments in it at their place, and then they can get real live data, how their floor is performing, how their tools are performing, how their equipment are performing, how the human being who is working in the shop floor, how that particular person is performing, and the supervisor or the production manager can have this data in the tip of their hand. And in case there is any violation, they can get an immediate notification and take immediate precautionary action, rather than waiting for the product to be tested and failed and then coming back to the manufacturing line. Yeah. So this has been a major change in which the industry is moving, and we have seen that many customers in India, as well as several customers in United States, who have onboarded this particular technology and have seen the benefit of that actually. Yeah. Rajiv,
Very,
back to you.
very nice, very nice, very nice. And I understand that like there is you got to have a safe work surface on the ESD, and the equipments needs to be protected. And what kind of the precautionary measures we can work on those?
Yeah. So, I mean, one of the very basic things is to ensure equipotential bonding. Yeah. That anything that you have in the shop floor is bonded to the same ground. Like it can be the surface of the table, it can be the chair, the flooring, etc. Yeah. Now, what we have seen is, so there is, I mean, if I talk about a factory where I visited recently, everything is very nicely grounded. The material is perfect. When it is measured, everything is fine. But what they are doing is the PCB is kept on top of a plastic surface, so that the surface on which the table itself does not get damaged. Yeah. So while the table itself is very well grounded, very much within the specification limits, but to protect the table, there is a plastic cover, and all the work is happening on top of the plastic cover. Yeah. So while we do all the necessary actions, but we also need to ensure that such oversights or such silly mistakes are prevented, so that our system is in place and still the system is not working, so that type of situation doesn't happen. Yeah.
Great, great. So now coming on the packaging, you mentioned a couple of times. So what kind of packaging materials normally you think should be used?
Right. Yeah. Now, when we are talking about packaging, we need to understand that there are two specific type of packaging. Yeah. One type of packaging is what we are using inside our ESD shop floor, and those are, so basically for internal handling of the material, etc., within the ESD protected area. Yeah. But on the other side, there is another type of packaging, basically, which we use for shipping from one factory to another. Yeah. Now, those type of packaging is what we call as shielding packaging. Yeah. Now,
Yes.
I will quickly go back to my screen share mode and try to explain this. Okay.
Yep.
So the type of packaging I'm talking about, like if you have to send from one factory to another, or you have a factory, there are two factory, and there is in between the two factories, you have a non-EPA, then the type of packaging that you need to use is called as shielding packaging. So basically, the shielding packaging looks like this type of bag, and this type of bag has if you look at the cross section of this bag, it has got three layers like this. Yeah. And why it is having these layers like this is because it's when we take this type of bag, put a current sensor in this and connect it to an oscilloscope, and close the mouth of the bag, and we inject 2000 volts on outer surface of this bag, this bag basically stops this external voltage from going inside. Yeah. And this type of bag specifically we use whenever we plan to take this material outside an EPA. Yeah. So this bag prevents this or shields from this external voltage. Yeah. So, so we have to just remember two types of packaging. one type of packaging which is inside our EPA or our ESD protected shop floor. And anytime we have to take our bags or materials or components outside the shop floor, we use a bag which gives a shielding function. And the way to test the shielding function is by injecting a voltage and sensing how much energy is retained through the current sensor when we connect to the oscilloscope. Yeah,
Excellent,
Rajiv.
excellent, excellent. So now coming on to this, I also studied or understood or I have visited few factories myself. I see that in certain areas the humidity needs to be maintained. What do you want to say on those?
Oh, thank you. That's a very, very important parameter. Yeah. So, I mean, when we talk about humidity, I mean, especially for example, when we go way up in North US or in Canada, I've seen that, the humidity is very low and that poses a major, major challenge in the factory actually. Yeah. And also, for example, in India, it can create a major issue for from a ESD perspective. And the reason for that is that any surface which is so basically any surface around us, whether it is our body, whether the table, the tweezer, the tools, everything is having its own capacitance. So basically it can retain charge. Yeah.
Mhm.
So the role of humidity is to remove the charges from these surfaces. Yeah. And the humidity that we recommend is this. Yeah. So I'm again sharing my screen.
Yes,
So the
please.
humidity we recommend is between 40 and 60%. Yeah. And why 60 and why 40? I mean, of course, there's an explanation, but we have seen that this is a very, very optimum range of humidity. Yeah. And a very easy way, and I'll stop sharing again. Yeah. And a very easy way to understand that, yes, our humidity is low is when you feel, you as a human being or we as a human being working inside the shop floor, we feel that our lips are getting chapped or our hand or our tip of our fingers are getting chapped. That's when we easily understand that the humidity is going to be very low in my shop floor and we need to take some steps. And of course, there are some advanced factories where there are automated mechanisms to detect the humidity and raise an alarm in place as well. Yeah,
Oh,
Rajiv, back
excellent,
to you.
excellent response. And Ankan, I think as far as ESD is concerned, quite a bit of information that you have given. Now, I want to understand how your company can help our audience. There can be a lot of people who wants to get some input about the ESD. How your company can play an important
Yeah,
role in
thank you,
this.
Rajiv, for that question. Yeah, yeah.
Yes.
So, I mean, of course, we are into training, audit, uh, measurement, etc. Yeah, but product qualification, etc. But also, what we do is failure analysis. Yeah. Now, it is very important to understand that the failure of the product, whether it's a LCD screen, whether it's a LED, whether it's a resistor, whether it's a memory component, is very important to understand that what is the source and what is the failure mode basically. Yeah, whether it is ESD, whether it is electrical overstress or something else. Yeah, or because of assembly issues, etc. Yeah. Now that is the support that we give to our customers. Yeah. Now what happens is that customers would have never thought that, okay, this is happening because of ESD, US, or some other failure mechanism. Yeah. So knowing that root cause helps the customer in defining the process capability they need either inside their labs or inside their shop floor, manufacturing shop floor. Yeah. And so that is one thing that we have seen that had been extremely effective, and customers are really hooked up when they see the results of the failure analysis that comes in. So we have got wide range of failure analysis techniques basically. And the other thing what I was telling you is about the future of the measurement, yeah, in within the ESD domain, doing quarterly measurement, doing biannual measurement. Now those days are slowly going away. Yeah. Now we are talking about measurement right now and getting the notification right now. Yeah. And when customers see the Power BI dashboards with all this ESD data, the customers have never thought of it actually. Yeah.
Yeah.
And it really helps because this dimension was never thought of, and now customers are really getting hooked onto it because it gives them real life view and gives themselves as well as their customers a real life view of what the ESD is and what the ESD is providing to them. Answer any questions with the team.
Excellent. Thank you very much, Ankan, for your time today because I know how busy you are and it's week is ending and Friday is a working day still in India and and also on the weekend also people work 6 days a week too. Having said that, for the audience, for the listeners, I know it is very difficult to log in and watch at the same time, but you can always watch the show at your ease as well because it's available on our YouTube link and we will share that again. With that said, ESD is definitely a very, very important and an integral part of electronics manufacturing, and definitely we have to prevent ESD. As Mr. Ankan explained, there are various methodology that can be used in preventing the ESD. And also, as you mentioned earlier, it used to be quarterly we used to get the ESD things checked and so forth. But now the things have changed. Now it's a digital world. Everything has to happen right now. So do not do not be lazy in checking your ESD activities in your plant, in your manufacturing area. You have to give a lot of importance because a little money spent is little money saved, and I would say larger money saved because that can prevent a lot of damages to your circuits and to your components. So with that said, one more episode, I'm signing off, your friend, your RJ Rajiv Kulkarni from Global Electronics on the electronics manufacturing. Next Friday we will have an interesting discussion with one of the contract manufacturing companies, the general manager of India. So stay tuned with us. Till then, please take care of your health and be happy wherever you are. Thank you very much.
Thank you.